In this video, we'll be looking at how to find the distance between a line and a point in a coordinate plane. So for any questions that have to do with coordinate planes, it's really helpful to actually visualize the coordinate plane, and it will help us to be able to kind of judge the answer that we're going to work out. So let's get a coordinate plane in here. Okay. So now that we have our coordinate plane, we can put our points in there. And so the first point is -5, 3. So somewhere around here. And our next point is 4, -6. So we have it down here. And that will make a line. So let's try and get a line as straight as possible without a ruler. And it's a line, so it keeps going that way, it keeps going that way. All right, and we have point 2, 4, and so that is about right here, and that's our point P. All right, so if we have a point and we're trying to get to a line, so I can go a long scenic route. I can, go right and then go down and then go that way and just, take a tour of the neighborhood, or I could just take the straightest possible route, which is actually going to be a perpendicular line from point P going to line L. So let's go ahead and draw that line. And it looks kind of like that. So it doesn't tell us exactly where they meet, but it gives us an approximate idea. All right, so that doesn't tell us the distance either, and we definitely need the distance. So how are we going to go about finding the distance? Well, there's a series of steps involved. First, and I'll just walk you through the steps first, and then we'll do them together after. So step 1, we definitely need to find the equation of line L. We'll be using it later. We also need to find the equation of the red line that we just drew, that perpendicular line. So let's call it R for red line. So find the equation. Oops, that's supposed to be an R. So find the equation of R. The third step, we need to find that point. Why do we need to find that point? Let's call that point something. Let's call it O. Why would we need to find point O though? Well, we need to find point O because if we find point O, then we can find the distance between O and P, which is our last step. So let's write that down, and then let's just jump right in. All right. So I think we are ready to begin this problem. All right, so let's jump into step 1. And in step 1, we have to find the equation of a line that passes through -5, 3, and 4, -6. So let's go ahead and do that. First, we need to, in order to get that done, we need the slope of that line. So slope, as you may know, is equal to y2 over minus y1 over x2 minus x1, rise over run. All right, so let's name these. We can call this x1, y1, x2, y2, and we get that slope is -6 minus 3 over 4 minus -5. So when we work that all out, we get -9 over +9, which just gives us -1. All right, so what do we do with that slope? Well, now we can pick one point on the line, and I pick this one for no special reason. I could pick the other one. So we pick one point on the line, and we can plug in to figure out what B, or y-intercept B, is. All right, so we know that the equation of a line is y equals mx plus b. If we use this point, 4, -6, we have that x is 4. So x is 4, and we know that y is -6, and we just found that m is -1. So now we can solve for b. and we get that negative 6 is equal to negative 4 plus b. So adding 4 to both sides, we get that b is equal to negative 2. Alright, so now we have our y-intercept and we have our slope. Our slope is negative 1, our y-intercept is negative 2, so the equation of line L is y equals negative m, which is negative 1, so we don't have to write that. So negative x plus negative 2, so we actually can just write minus x or negative x minus 2. So that's our step 1 complete. We found the equation of line L. Now it's time to find the equation of line R. And just so you remember, line R is that perpendicular line here that we just formed. Okay, so in order to figure out the equation of line R, we're going to follow some similar steps. But we first have to remember that the slope is going to be different. So if the slope of line L is negative 1, as we found previously, the slope of the perpendicular line is the negative reciprocal. So when you change the sign of negative 1 and you flip it, the negative reciprocal is just positive 1. So the slope of line R is just positive 1. And we do have a point, so this is step 2 that we're about to start here. So we do have a point. The point that it passes through, line R, is 2, 4, and the slope is 1. And now we can follow the same steps we did to figure out the equation of that line. So y is equal to m, x plus b, and we can plug in 2 for x, 4 for y, and 1 for m, and we get that 4 is equal to 1 times 2 plus b. So b is actually equal to 2. So the equation of line R is y equals 1x, so we can just write x, plus 2. And so now we have the equation of line L and of line R. So the third step that we are about to do now is find the coordinates of O. So keep in mind that line L and line R do meet at point O. So you want to solve this equation simultaneously. So we have here that y is equal to negative x minus 2 and y is equal to x plus 2. And where these two equations meet is the point that we are looking for. So we can do a little substitution here. Since y is this and y is also this, that means this has to be equal to this. So we can now just write that negative x minus 2 is equal to x plus 2. So solving this, we can subtract 2 from both sides, and we get that negative x minus 4 is equal to x. Now we can go ahead and add x to both sides, and we get that 2x is equal to negative 4, which means that x is negative 2. Alright, so we now know the x-coordinate, and it seems our graph wasn't that great because it's a little off here. If you take a look, it doesn't look like negative 2, but it's close. Alright, so now that we know the x-coordinate is negative 2, we can go ahead and plug in to figure out our y-coordinate. But plug into what, you ask? Should we plug into this equation or should we plug into this equation? It actually doesn't matter. You choose whichever you prefer. So I'm going to go ahead and I pick this one because I prefer seeing less negative signs. So we know that the relationship between, so I'm filling up this page here, but we know that the relationship between x and y is that y is equal to x plus 2. I just got it from that equation. So that means that y is equal to, we just found that x is negative 2, so y is equal to negative 2 plus 2. So y is actually equal to 0. So what then are the coordinates of this point, of point O? Well, the coordinates of point O are -2, 0. And I'll write that on the next page. We just need some more space here. So we're almost there. We're almost to the point where we can figure out the distance between our point P and our line L. So at the very beginning of the question, we were given the coordinates of point P as 2, 4. And it took us a lot of work, but we finally figured out that the coordinates of O are -2, 0. And now that we have 2 points, all we have to do is use the distance formula or the Pythagorean theorem to figure out the distance between these 2 points. So we know that D, according to the distance formula, D is equal to x2 minus x1 squared plus y2 minus y1 squared. All right, and so we can number these points, number and name these points. We can make this x2, y2, and this x1, y1, and we can go ahead and plug into our distance formula. So we have x2 as 2 minus x1 as -2 squared plus y2 is 4 minus y1 is 0 squared. So that gives us 4 squared plus 4 squared, which gives us, oh, of course, square rooted, which gives us 16 plus 16, the square root of 32. At this point, you could go ahead and simplify it if you know how to work with radicals, or you could put this in your calculator, or you could leave it as root 32, depending on what class it is that you're in and what your teacher requires.